So if you're a developer who uses AI, you've definitely been there. You know that getting a model to do exactly what you want can be, well, frustrating. Today, we're going to fix that. We are moving way beyond just simple chats and diving headfirst into the world of prompt engineering, where your words become just as precise and powerful as your code. Just look at this. On the left, you've got a simple, casual query. Tell me about JavaScript closures. The result you get? It's totally unpredictable. But on the right, now that is an engineered prompt. It's defining a role. You're a senior developer. It sets an audience. You're talking to a mid-level engineer. And it even requests a specific format. Include a code example. This, right here, is the fundamental shift from just asking a question to designing a precise instruction.
And that really gets to the heart of it. For a developer, this isn't some soft skill. No, this is a technical discipline. You're not just stringing sentences together anymore. You are architecting a function call using plain English.
All right, so here's our game plan for building up this skill set. First, we're going to lock in that engineering mindset. Then, we'll peek under the hood at a prompt's architecture. From there, we'll master 3 incredibly powerful techniques to control the AI's output. And finally, we'll wrap it all up with a handy checklist you can use for every single API call you make.
So that's the core mindset shift we're talking about. From this point on, every prompt you write is a function call. We're expecting predictable, reliable outputs. Now, let's see how that actually works on a technical level.
So what is your application actually sending when it calls an AI API? It's not just a single string of text. It's a structured object. And really understanding this architecture is the key to getting that fine-grained control over the model.
You'll find that in most modern LLM APIs, you're sending an array of messages, and each one has a specific role. Think of the system role as the constitution. These are the global, unbreakable rules for the AI. The user role, that's your dynamic input, kind of like an argument you'd pass to a function. And the assistant role, that represents the AI's past responses. Now this is where it gets really interesting, because it means we can actually show the AI what a perfect response looks like.
So how do we show the AI what we want? Well, this brings us to what is honestly probably the most powerful technique in a developer's toolkit. Instead of trying to explain a bunch of complex rules, we can just demonstrate them.
It's called few-shot prompting, and it's like creating a tiny, on-the-fly training set right inside your API call. You just provide a few pairs of user questions and ideal assistant answers, and you essentially teach the model the exact pattern you want it to follow. It's so cool. Let's check out a real-world scenario. Imagine your app needs to translate content, but you have to keep all the technical terms in English. If you just tell the AI the rule, which is called a zero-shot prompt because it has 0 examples, the results can be all over the place. The model might misunderstand or just completely forget the instruction.
And this shows the solution perfectly. Look at how we've built a little conversation history here. We provide a user input and then a perfect assistant output. We do it again, the AI sees this pattern, the technical terms stay in English, and it just continues that pattern for our real question. It's super elegant, and it requires 0 complex instructions.
For any developer building a real application, random conversational output is an absolute nightmare, right? It just breaks all your parsers. So for our next technique, let's look at how we can get perfectly structured, reliable data on every single call.
I mean, think about it. If you're building a quiz generator or a tool that's supposed to populate a database, you can't afford for the AI to sometimes give you perfect JSON and other times wrap it in a chatty response like, "Of course, here is the JSON you requested." No way. You need raw, valid data every single time.
And the crucial insight here is this. Don't just ask for JSON. Define the JSON. The most reliable method by far is to give the AI the exact schema you need it to follow, something like a TypeScript interface or even just a simple JSON object with empty values.
See, providing a schema like this acts as a powerful constraint on the model. You're not just asking for JSON anymore. You're giving it a template and saying, fill this out, nothing more, nothing less. This just removes all the ambiguity and basically guarantees an output that your application can immediately parse without any issues.
Okay, so now we can control the format of the output. That's huge. But what about the quality of its reasoning? For really complex tasks like debugging code, the final answer is only as good as the logic that produced it.
Large language models can sometimes make these very confident-sounding mistakes or hallucinations, basically by taking logical shortcuts. Well, the chain of thought technique is the solution. It forces the model to slow down and show its work, making it articulate its reasoning step by step, which dramatically reduces these kinds of errors.
And you implement this by literally putting the steps right into your prompt. Before you even give it the user's code, you instruct it. First, think step by step. Second, check for syntax. Third, check the logic. And only after completing those steps should you provide the final answer. This forces a much more rigorous and reliable process.
Okay, we've covered some seriously powerful individual techniques. Now, let's bring it all together into a simple, actionable checklist you can run through every single time you design a prompt for your application.
Here it is. Just 4 questions to engineer a great prompt. 1. Role. Did I give the AI a clear identity with a system prompt? 2. Context. Can I improve performance by showing it examples with few-shot prompting? 3. Output. Have I defined the exact JSON structure I need? And 4. Constraint. Have I explicitly told the AI what not to do? Things like do not apologize or no conversational text.
And here is one last pro tip to really operationalize all of this. Start treating your prompts like reusable code. Use delimiters like triple quotes or even XML tags to safely separate your instructions from user input. Then, use variables to turn your prompts into templates. This is what transforms them from just one-off text strings into powerful, reusable functions you can call from anywhere in your codebase.
So, this leaves us with one final thought-provoking question. If prompting really is programming in natural language, and your prompts are a form of code that executes on this massive model, are you giving them the same attention to structure, testing, and detail that you give the rest of your codebase?